Hi Algebra students, please find your 5-6 squares of binomials notes template. Try the two warm-up questions for us. This is a review from past sections in Chapter 5. Okay, just to review, the first warm-up question, you're going to do 4 little mini multiplication problems. The first term, 2x, I drew blue arrows to each of the terms in the second set of parentheses. That gives us 4x squared plus 6xy to the third. And then the second set I drew red arrows for, and just be careful that you are taking into account this subtraction sign turns to a negative. So that's going to give us negative 6xy to the third minus 9y to the sixth. Those two middle terms cancel, leaving us with a final answer of 4x squared minus 9y to the sixth. You could also have plus negative 9y to the sixth. On the second warm-up problem, make sure that you're pulling out a common factor of 9 first, leaving us with two terms in parentheses, 9a to the fourth minus 4x to the sixth, which is a difference of squares. When you take the square root of 9, you get 3. Square root of a to the fourth is a to the second power. So we need both a positive, a sum, and a subtraction, a negative. For the rest of Chapter 5, you're going to be doing factoring, but you're going to be looking for certain patterns. And today we're going to talk about the perfect square trinomial pattern. So we're going to start off by talking about what it is that you're looking for that qualifies a polynomial as a perfect square trinomial. First of all, it's kind of self-explanatory, but it is a trinomial, meaning that it has 3 unlike terms. So for a polynomial to be a trinomial, you're looking for 3 terms. The first and third terms are perfect squares, and you should be familiar with that terminology. You can take the square root of them and get something that is an integer and has an integer exponent. The middle term is twice the product of the two original terms. And I'll show you what that looks like when we identify them later. Which means if you multiply the first term and the last term by 2, it is going to give you the middle term. And the sign of the middle term has to match, or matches, the sign inside the original binomial. So let's jump into an example where we look at what we're going to do here. Now, for a plus b squared, remember when it's got the addition sign, it's got 2 terms, you need to rewrite this as a plus b times the quantity a plus b. Otherwise, you're tempted to just tell me it's a squared plus b squared. You need to multiply every term by the other 2, and we have an acronym for that, which you should be familiar with by now, is FOIL, just to help you remember. So first, outer, inner, last. So a squared from a times a plus b times outer, ba, which is really a, b again, I always put them in alphabetical order, plus b squared, and then you've got 2 terms that you can combine. These are like terms, so you should have a product of a squared plus 2ab plus b squared. Over here, when it's subtraction, again, rewrite that to be a minus b times the quantity a minus b. When we go to do our FOIL, first gives a squared, just like the last one. Outer gives us a negative ab. Inner gives us a negative ab. And last gives us a positive b squared because it's a negative b times a negative b. Combining like terms, we're going to have a middle term this time of negative 2ab or minus 2ab. So for example 1, we're going to go ahead and write that out as 7u minus 3 times the quantity 7u minus 3. We're going to follow our acronym, FOIL. First gives us 7u times 7u, which is 49u squared. Outer gives us 7u times negative 3. Our inner terms give us negative 21u. Our outer. Our inner also give us negative 21u. And our last gives us positive 9 because you've got a negative 3 times a negative 3. Combining those middle terms, 49u squared minus 42u plus positive 9. Try the your turn right next to that, squaring 3p squared plus q squared. So our your turn gives us a final polynomial of 9p to the fourth plus 6p squared q squared plus q to the fourth, and you can see my work above. So the second part of 5-6, we're going to talk about factoring those perfect square trinomials that we defined earlier. These are the questions that you want to ask yourself before you factor it as if it were a perfect square trinomial. So this kind of is the checklist to make sure it actually is. You want to check if the first and the third terms are perfect squares. You want to check if the middle term is twice the product of the first and the last term. And number 3 is if those two things qualify, you can factor it. So if we jump into an example like example 1, we're just going to run through that checklist that we just saw above that. So if you look at x squared plus 6x plus 9, the first question is, are the first and the third terms perfect squares? So if you look at x squared, is that a perfect square? Yes, it is. So if you take the x squared and you take the square root, you're going to get a x. 9, is it a perfect square? Yes. If you take the square root of 9, it's going to give you 3. Pardon the cat in the background. And for letter B, you want to make sure that the middle term is twice the product of this one, of x squared, the square root, and 9. So we got x and 3 here. So the middle term has got to be twice their product. So 2 times 3x, which is 6x. So yes, that works. And I'll just kind of write my work out there a little bit. 2 times 3x equals 6x. And that's how we knew. So we can jump into factoring this. So what we need to do is we are going to make it into something that is square, just like the before on the things that you just FOILed. And you take the first term square root, so x. You take the last term square root, which was 3. And since we've got all positive signs, this should be an x plus 3 squared. You can check that by writing it out as if you were going to FOIL it, and then kind of FOIL it in your mind and make sure it matches the original. You would do first, which is x times x, which is x squared. That works. 3 times x, and 3 times x gives us 6x. And 3 times 3 gives us 9. For the next one, you want to check first is, can you take the square root of 4x squared? Yes, you can. It's 2x. Can you take the square root of 25? Yes, you can. It's 5. And is the middle term twice the product? You can ignore the subtraction sign for now. Twice the product of these. Well, these give us 10x, and we would need to double that. So is the middle term twice their product? Yes, it is. It's 20x. So jumping in, we need a set of parentheses. We're going to square it. We need this first term to go here, so 2x. We need the last term to go here, so 5. And then to get the sign, you want to look at the sign in front of the middle term. It should match. So because that is a subtraction sign, this should be a minus. And then again, I always recommend to students, especially when you're starting out factoring, go ahead and simplify it out and make sure that it matches your original so that you know you've done it properly. So 2x and 2x gives us 4x squared. That works. 2x times negative 5 and negative 5 times 2x, that gives us a total of negative 20x, which works. And negative 5 times negative 5 gives us positive 25, so that works as well. All right, now we're going to try this one. Square root of 64u squared is 8u. Square root of 81v squared is 9v. In order for this to work, we have to have double the product of these match that one. So this gives us 72 uv, but we would have to double this. And because the middle term is just the first term square times the second term square root, this does not work. So this is actually not a perfect square trinomial, and you're going to write NF, which stands for not factorable. Now sometimes students go, well, it seems too good to be true that it matches just their product, so let's try it out. And they try it out, it will not work. You can go ahead and FOIL that out if you want. Now that you've kind of mastered perfect square trinomials, let's talk about what if I have 4 terms that I need to factor here. And before you get too intimidated, I want you to look at the 4 terms that are given to you for example 2. We've got x squared minus 12x plus 36 minus y squared. And if you've ever heard that Sesame Street, which one of these is not like the others, which one of these just doesn't belong, you should be seeing that the minus y squared just kind of doesn't fit in. This looks like a perfect square trinomial. We've got an x squared term, we've got an x term, we've got a constant at the end. That minus y squared is kind of the oddball. So that's actually, we're going to use that pattern there, and we're just going to factor the first 3 terms separately, and then we'll talk about what to do with the y squared. So just kind of ignore the minus y squared for now, and let's check to see if the first 3 terms are a perfect square trinomial. So can we take the square root of x squared? Yes, we can. It's x. Can we take the square root of 36? Yes, we can. It's 6. This is a minus situation, so we should have minus, and this should be squared. Now we're just going to drop down the minus y squared. We didn't use that yet. Okay? Now if you look at this big picture overall, we've got a difference of squares happening here. It's this whole thing, this whole grouping squared, minus this y squared. Okay, so those are both squareds. So what we're going to do is we're going to pretend that this is just a regular difference of squares. We would have 2 sets of parentheses. I'm going to make mine nice and big, and you'll see why in a second. And we're going to take what the square root of the first term is. Well, we've got 2 groupings of x minus 6, so to take the square root, we've really got an x minus 6 happening in both of these. We've got a minus, which means there should be a plus here and a minus here following that difference of squares pattern that you learned in an earlier section. And the square root of y squared is going to give me y. So I've really got 3 things happening in these parentheses, and that's okay because we are doing a grouping of 2 terms for the first one and just a single term for the second one. So the whole factored form would be quantity x minus 6 plus y times the quantity x minus 6 minus y. And to wrap it up, let's take a look at this your turn, and we'll do it together. So this is another 4 terms, so you kind of have to figure out which one doesn't belong. And there's a special note here that says we need to group the trinomial square, which is hint op sum reversed. So if you look at these, what 3 terms seem to go together is actually these last 3, y squared plus 6y minus 9. The problem is this little bugger. Because there's a minus sign in front of it, we need to actually kind of reverse op sum, and that's what that note is about. Because if I take x squared, I want x squared minus something. But the problem is I don't have that -1 pulled out of each term. I just have it being minus y squared plus 6y minus 9. So I kind of need to pretend that I'm going to do a reverse op sum. I'm going to pull out a negative from negative y squared, that gives me a positive y squared. Pull out a negative from positive 6y, that's minus 6y. And pull out a negative from negative 9, that's going to give me a positive 9. So I'm kind of doing an opposite of each of those 3 terms after the set of parentheses, or pardon me, after the subtraction sign, which is the reason this whole mess happened. Whenever the perfect square trinomial is following the subtraction sign, then you've unfortunately got to do this extra step. So if we look at this now, we've got a perfect square trinomial, second, and just an x squared in front, which is kind of nice. So I'm going to split this up into, I want to factor the perfect square trinomial first. So that's going to give me, if we take the square root of y squared, we're going to get y. Square root of 9 is 3. I want this to be squared. It's going to match the middle term sign, so it's going to be a minus. And now we're down to a difference of squares. So I want two big sets of parentheses for 3 terms. The first term is easy because the square root of x squared is just x. But I want a plus and I want a minus, and you're going to need kind of parentheses within parentheses because we're going to have plus y minus 3. Don't really need parentheses there, but they are there because we're taking that whole grouping. And we need minus y minus 3. And the reason you need parentheses is if you simplify this even more, first set of parentheses doesn't change. Second set changes to minus y plus 3. Kind of weird there, but we're doing a negative or an opposite of y and an opposite of a negative 3. So we've got our difference of squares there, and we factored those, and then we're down to the final factored form right there. Please bring any questions you have to your math teacher the following instruction day. And please understand that factoring takes practice, so don't skip any of the class practice, don't skip any of the homework assignments. You want to make sure you're getting all of the practice necessary because factoring is one of the most challenging skills we're going to cover this year. All right.